Okay, and the party continues. This would be section 1-4, day 2. We're solving quadratic equations, and we're finally getting to the quadratic formula. Often in mathematics, you're taught the long way of solving a problem first. Then the longer method is used to develop shorter techniques. The long way stresses understanding, and the short way stresses efficiency. For instance, you can think of completing the square as the long way of solving a quadratic equation. When you use completing the square to solve quadratic equations, you must complete the square for each equation separately. In the following derivation, you complete the square once in a general setting to obtain the quadratic formula, a shortcut for solving all quadratic equations. So here is our very general a type of quadratic equation. You know, a, some number a times x squared, plus b, some number times x, plus or minus a constant, and that's equal to 0. Now, you know, usually when we were doing the completing the square, there were numbers for a and b and c, and we'd work it through separately for each equation. But what if we solve this in a very general term? Ax squared plus bx plus c equals 0. You know, we're going to solve this for x without ever plugging in a number for a, b, or c. And we did completing the square yesterday, and we remember that the first step is always to get your leading coefficient equal to 1. So here I'm going to divide through by a. We don't know what a is, it's a number, but we're going to divide through it by it to get our x squared with a coefficient of 1. So now we have ba times x, or b divided by a times x. And then here we have c divided by a, and we're going to move that over. Here it's a plus. We're going to move it to the other side. Now it becomes a minus c divided by a. So we're going to get ready to think about completing the square. And the way I showed you to do it yesterday, you know, we're going to have some binomial perfectly squared here. Our leading term is an x squared, so this has to be an x. We have a plus ba, so this is a plus. And remember, when we bring this down, we cut it in half, or with a fraction, that's as simple as doubling the denominator. So when I bring this down, it's going to be b divided by 2a. And then we want to find out what goes here and add that to both sides. Remember, sort of we're bringing this back up and squaring it. So it's going to be plus, our numerator is b squared, and our denominator would be 2a quantity squared, or 2a times 2a, which is 4a squared. And if I add 4a squared divided into b squared on this side, of course I have to do it on this side. B squared over 4a squared. And that's equal to, what we're going to have to do over here is get a common denominator. And this isn't too bad. You know, here on the right we have 4a squared, over here we have 4a. So what would I multiply this denominator by to make a match? Well, I'd have to multiply it by a 4a. 4a times a would be 4a squared. So I also have to multiply this numerator by 4a. So that becomes a 4ac. And let me move that negative out there. That is a negative, don't forget. Let me extend that divider line. So now we do have the common denominator. Our denominator is 4a squared. Our numerator is negative 4ac plus b squared. And let's write that backwards. B squared minus 4ac. So our leading term isn't negative. B squared minus 4ac. Alright, so we did, you know, the very beginning of our basic completing the square algorithm. And we have this set up. Now we are ready to square root both sides to extract our roots. So on the left, that's the easy one. We square root a quantity squared. Those cancel. So now we have x plus b over 2a. And we're going to square root this side. And I'm going to do numerator and denominator separately. We will leave, remember when we extract these roots, we do have a plus or minus. And that will just go with the numerator here. Plus or minus the root of b squared minus 4ac. And when we square root this denominator, this is a perfect square. The square root of 4 is 2. The square root of a squared is a. So now we have our radical over 2a. And look at that, our denominators are common. So we are going to subtract, you know, this b divided by 2a from each side. And we'll be able to combine it because the denominators are already common. So now we have x equals, we're going to subtract this out. when we subtract it out, we're going to move it over here, and it'll make it into a negative term. So that's going to be a negative b over 2a, and we'll put it all over, one common denominator. So now here on this side, we have negative b plus or minus the square root of b squared minus 4ac, that entire numerator, divided by 2a. And remember, we were solving for x. So if we want to find the roots of a quadratic equation, as long as we identify the coefficients, the a that is in front of x squared, the b that is in front of the x term, and the c that is the constant, we can plug those in for these a, b's, and c's and compute our roots this way. And of course, what we just found there, you should recognize that from Algebra 2, that's the quadratic formula. So the solutions of a quadratic equation in this general form, ax squared plus bx plus c is equal to 0, as long as our leading coefficient does not equal 0, those solutions are given by this quadratic formula. X equals negative b plus or minus quantity, the square root of b squared minus 4ac, all divided by 2a. A little study tip here, you can solve every quadratic equation by completing the square or by using this quadratic formula. Because remember, we got this quadratic formula by the completing the square method. So no matter what quadratic equation I throw at you, you can always solve it with the quadratic formula or completing the square. So in the quadratic formula, we have a quantity under the radical sign. Right here, this b squared minus 4ac is under the radical. And remember, what don't we want to see happen under a radical, an even indexed radical? We don't want to see negatives there. And that here is going to give us a clue as to what's going on. So in the quadratic formula, the quantity under that radical, b squared minus 4ac, is called the discriminant. It's got its own special name. The discriminant is just b squared minus 4ac of the quadratic expression. It can be used to determine the nature of the solutions of the quadratic equation. So the solutions of a quadratic equation can be classified as follows. We look at the discriminant, b squared minus 4ac. If that discriminant is positive, then the quadratic equation has two distinct real solutions, and its graph has two x-intercepts. So for number one here, if you take a quadratic equation and you graph it, it's going to be a parabola. And if your discriminant is positive, it just means the parabola hits the x-axis twice. Here we hit it once here and once here. That is number one. If we have two positive, or if the discriminant's positive, we have two real solutions, that's where we cross the x-axis. We might have the discriminant exactly equal to 0. If this is the case, then the quadratic equation has one repeated real solution, and its graph has one x-intercept. And you might be thinking, how in the heck would a parabola only intersect the x-axis once? Well, it's going to do it just by coming down and just hitting it and bouncing back up. So this parabola hit at only one spot. That is our one real solution for a 0 discriminant. And the last case, b squared minus 4ac, if the discriminant turns out to be a negative number, then the quadratic equation has no real solutions, and its graph has no x-intercepts. So it might be the case that our parabola, maybe it's up here, opening up, and it's never going to hit the x-axis, or it could be down here below, opening down, and it never hits the x-axis. No real solutions. We will shortly be getting to dealing with negatives under radicals with imaginary numbers or complex numbers. And that would be a solution to a quadratic with a negative discriminant. So here, make sure when you're doing the homework or taking a test or a quiz, always read the directions. Here it says use the discriminant to determine the number of real solutions. I've seen students in the past that dive right in and solve the equation for the solutions. They're not doing what the directions asked. They were only asking for how would you classify the solutions by using the discriminant. So our discriminant is b squared minus 4ac. In this problem, our a value is negative 5. That's in front of our squared term. Our b value is negative 4. That's the number in front of x. And our c value is positive 1. So here I'm going to plug in my b, that is negative 4, and that's quantity squared, minus 4 times a, which is negative 5, times c, which is 1. So negative 4 squared is positive 16. And then we have negative 4 times negative 5 is positive 20, and times 1 is still that same 20. And when we add these up, the number doesn't matter. This 36 doesn't mean anything by itself, but it is positive. We have a positive answer, which that means we have two real numbered solutions. The graph of this, if you were to graph this parabolic curve on a calculator, it would cross the x-axis twice. So we have two real solutions. And let's see this one down here. There's no number in front of x squared, but we know there's an implied 1. So our a value is 1, our b is negative 4, and our c is positive 4. The discriminant is b squared minus 4ac. Our b value is negative 4, and we're squaring it, minus 4 times a times c. So here we have negative 4 quantity squared is positive 16, and then we're minusing 4 times 1 times 4 is 16, and 16 minus 16 is equal to 0. And if we have a 0 discriminant, that means we have one real solution. That parabolic curve is just going to come down and touch the x-axis at one point and bounce right back up. Alrighty, so that's our discriminant. Again, when you're doing the homework, make sure you read the directions. Don't do more work than you have to. We didn't have to completely solve these. We just needed the discriminant. So now example 6, quadratic formula, two distinct solutions. So the quadratic they've given us is x squared plus 3x equals 9. We want to use or set this up equal to 0 before we start pulling out our ABCs. So I'm going to subtract 9 from each side. X squared plus 3x minus 9 is equal to 0. So the number in front of our squared term is 1. Our b value is positive 3. Our c value is negative 9. And we just start plugging them in. X equals negative b. So our b value is 3. Plus and minus. We have our radical. Now b squared. That would be 3 squared or 9. Minus 4 times a is 1 times c is negative 9. And that is all divided by 2 times a, or 2 times 1 is 2. So let's work under the radical and see what we have. We have our 9 minus, and then 4 times 1 times negative 9 would be negative 36. 9 minus a negative 36 turns to add the opposite. So we're going to wind up with a 9 plus 36 under there is a 45. All divided by 2. Negative 3 plus or minus root 45 divided by 2. And I guess now that I look at it, we do have a perfect square hidden in 45. 45 is 9 times 5. And 9 is a perfect square, so we could bring that out. So our final answer here, our best answer, we're going to have our negative 3 plus or minus. The square root of 9 comes out as a 3. 3 times the square root of 5. And there's our two distinct solutions. Is that the last example? Yeah. Time for some practice problems. 65. Read the directions. You're not solving, you're just finding the number of real solutions with the discriminant. In the next two, use the quadratic formula to solve. So pause the video and give them a shot. So we have, here we're just worried about the discriminant, b squared minus 4ac. Our b value is 4, so we're going to have 4 squared minus 4. A is an implied 1 in front of the squared term. And c is a negative 32. Ooh, that's a biggie. So 4 squared is 16 minus 4 times 1 times negative 32. That's going to be negative 128. And we are minusing a negative. This is our subtract sign, and this is a negative 128, so we add the opposite. And we don't even really need to add that. Remember, we're only worried about the sign. That is definitely going to be a positive answer, and positive discriminants mean two real solutions. All right, easy part's over. Now let's do a little quadratic formula. So our first one here, it's all ready to go. We got our squared term, our x term, our constant. It's equal to 0. So I'm going to come scratch up here. Our a value is 2. our b value is -1, our c value is -1. Let's start plugging those into the quadratic formula. We start in our numerator, x equals negative b, and b is a -1, plus or minus, and then we have our radical. Under the radical is b squared, -1 squared is +1, minus 4 times a times c. And that's all divided by 2 times a. A is 2, so 2 times 2 is 4. And let's clean this up a little bit. Here we have minus a -1, that turns to a +1. And then we have our plus and minus, and then we have our radical. Let's see what we got under the radical. 1 minus 4 times 2 times -1 is -8. So we add the opposite. Ooh, that turns into a 9, and that is a perfect square. So we can even make this look a little better. Get that out of there. So we'll come over this way. We have 1 plus or minus the square root of 9 is 3, and that's all divided by 4. And let's even see if we can figure out exactly what these solutions are. Because remember, this answer here is 2 answers in 1. First, we're going to look at the plus root, the positive. 1 plus 3 over 4. 1 plus 3 over 4. And then we could come down here and do the minus. 1 minus 3 over 4. Well, 1 plus 3 is 4 over 4, which is 1. Down here, 1 minus 3 is -2 over 4, which is -1/2. There's, since we got rid of the radical, it's easy to see what those answers are. 1 and -1/2. All right. Let's check out number 80 down here. And this one, it's not given to us in the form that we really want. Remember, we want our x squared first, and then our x, and then our constant at the end. So I'm going to move everything over here to the left. Here it is a -x squared. It's going to hop over and become a positive x squared. We had a 4x over there to begin with. That's a positive 4x. This positive 8 moves over and becomes a -8, and that's equal to 0. So we extract our ABCs. A is 1, B is 4, C is -8. And let's get this out of here. Give me a little more room to write. And we start working on the quadratic. X equals, numerator is -b, or -4, plus or minus. We have our radical. B squared is going to be 4 squared, or 16, minus 4 times a is 1 times c is -8. All divided by 2a, or 2 times 1 is 2. So x equals, we have our denominator 2, numerator -4, plus and minus. And let's see what happens under this radical. So here we have 16 minus 4 times 1 is 4, 4 times -8 is -32. And 16 minus a -32, we add the opposite, and that becomes a 48 under the radical. Is there a perfect square hidden in 48? Yes, there is. That would be 16 times 3. So this is going to work out a little bit nicer here. We can pretty this up a little bit. Denominator 2, numerator -4, plus minus. The square root of 16 is going to come out as a 4, and then we're going to have a radical 3 left. And that's a pretty good answer, but we could make it a little bit nicer. If you notice, every leading coefficient is divisible by 2. And let's see here. This -4 is divisible by 2. This number in front of the radical is divisible by 2, and our denominator is divisible by 2. So we're going to divide. -4 divided by 2 is -2, and we'll have our plus minus. 4 divided by 2 is 2, and then we have our square root of 3. And there's our final answer, 2 solutions to the quadratic equation. All right, a little homework for this section. Page 118, label your assignment 1.4 day 2, and we have these problems from 59 up to 83. So have fun with those, and I'll see you in class tomorrow.